So here's a little quick help video of simplifying radicals. What you're trying to do is find where your perfect squares 1, 4, 9, 16, 25, so on and so forth, basically are hidden in these radicals. So if I take any radical, what I want to do is break it down into two other radicals, which would multiply, like if I did square root of 9 times square root of 2 would multiply to give me 90. Now what I've done here was I found a perfect square of 9. I know 3 times 3 gives me 9. So I would simplify this to, now I could simplify the 10 to 5 and 2, but realize when I do that, I end up with two prime numbers here. So there's not much I could do. Neither of these are perfect squares. So actually I would go back to where I came from and just leave it as a 10. And that would give me 3 and 10 as a final answer. Now let's say I did square root of 90, but I didn't know 9 and 10 went into it. And I said square root of 3, square root of 30. And then I broke down the 30 into square root of 3, square root of 10. Same thing when you're simplifying radicals. If you have two radicals that repeat themselves, square root of 3, square root of 3, recognize that square root of 3 times square root of 3 is square root of 9. And square root of 9 is 3. So this also would break down to 3 square root of 10. And then everything kind of stems off of that. Like, yeah, I could start with square root of 2, square root of 40 here, but I want to look for a bigger number to basically work with to kind of streamline my work. So I'd rather do a square root of 8 and a square root of 10. I know that the 4 is hidden within the 8, so I'll do square root of 4, square root of 2. This is a good example too because there's not much I could do with the 2 or the 10. So I'm going to leave those as is. I do have a perfect square in my 4, and square root of 4, 2 times 2 is 2. So I get 2 square root of 2, square root of 10. But then I should have recognized actually that I can break this 10 into a square root of 2 and a square root of 5. So these actually will repeat themselves too. So if I have two square roots that repeat themselves, now I have, let's just look at a square root of 4. I have the two square root that repeat themselves. And I have the square root of 5 here. So square root of 4 is 2. These two repeat themselves. So square root of 2 times square root of 2 is square root of 4, which is just 2 again. And then I'm left with the square root of 5. And that gives me 4 square root of 5. And that would be the distance if I'm using on a coordinate plane, or if I'm doing Pythagorean theorem, this would be the measure of what I'm looking for. And we'll get to this later on here. Just a couple quick ones. 109 and 12. I just keep breaking this down. 4 and 3. I found two perfect squares. And I end up with a 3, a 2, and a square root of 3. This gives me 6 square root of 3. I think you get the idea from here. I don't really want to look at this one. I would like to look at one like a 58, where you break it down into 2 and 29, and because you've broke it down into two primes, actually square root of 58 would be your most simplified answer. So this would be a final answer here. You can't break this down. This can't be simplified because there aren't any perfect, we'll call them PS, perfect squares hidden inside this. So this would be left as a 58.